Hello everybody, Bill Sky the Rust Guy, and another video on the Rust programming language. Today we're going to talk about variable or data casting. Now what does that mean? That means converting one data type to another. Some languages make that easier than others. In C and C++, I can copy a floating point to an integer to a floating point, no problem. In Rust, it's a little more involved, not too much. It doesn't take very much to get used to it. But it is a little bit different, so that's what we're going to be doing. Now this, you might think this is very boring, but you're going to find out you need to use this. Now, if you take a look at my getting keyboard input into a Rust program, the previous video to this one, I believe was number 5, that one we've already done some of that. So I'm going to be referring back to that video quite a bit, but we're also going to be doing some new stuff in this video. So let's get to the code. All right, so I'm going to go ahead, and I'm on Linux here. Again, you can use any operating system. It doesn't matter. The languages like C or C++, very portable, at least the source code from operating system to operating system. But I'm on Mint Linux again, and some people say, why are you on Mint Linux? Linux is just easier for me as a developer. It always has been. A lot of people feel that way. But anyway, so a lot of developers, I should say. So let's go. You can see my keyboard input project here. And I'm just going to go ahead and use cargo, and I'm going to call this var casting. And there's my var casting folder. I'm going to go into that, and I'm going to open up my main.rs file. I'm going to go down to terminal. I'm going to go to the parent folder, and I'm going to say cargo build. Make sure that's working. That's going to create a target, debug. And I believe it was var casting. And there we go. So my project's all ready to go. And I really should never have to look at my folder again or my directory. All right, so to actually do this, well, before we do this, as I say in many of my other videos, I always like to say program ending. And if you saw some of my other videos, especially the keyboard input video, you saw where that actually came in very, very useful. So what we need to do is we need to create a bunch of variables so I can demonstrate casting, so I can demonstrate conversion. So what I'm going to do is I'm going to create a whole bunch. Let's create a 32-bit one. And to make things a little faster, I don't think much. So we'll be saying 64-bit, F64. Okay. So let's create an integer. Now, if you're not really sure what I'm doing here, take a look at my defining data video in my Rust playlist, and I talk about how to do all of this. Okay, let's do another one. Yes, you can create 8-bit integers. We're giving them all values. All right, let's do a char. So I'm going to say let mute a char. Let's give it a single character. Now let's do some strings. So it's going to let mute. And let mute a string float. All right, so I think we've got all of our variables set up there. Now I'm going to go ahead and build this, and it works good. Okay. So let's first of all do what you might think is completely obvious to do. You might say, I want to convert my 64-bit integer into a 32-bit. So if I say integer 32-bit equals integer 64-bit, and you could actually do this in C and C++ and other languages as well. Cargo says, nope, you can't do that. You cannot just copy a larger to a smaller. What about going over to the other way? What if I go 64-bit to 32-bit? I get people that ask me that. People, by that I mean students. Cargo doesn't let you do it. You can't just copy those over. So, and even going from a string to a float or a string to an integer or whatever, that's even worse. So there is specific syntax in Rust, and the way you do that is you integer 32-bit equals float Yeah, let's go ahead and convert. No, let's say integer 32-bit equals integer 64-bit as unsigned 32. So that as keyword, along with the data type you want to convert it to, in this case unsigned 32, is what you need. And let's make sure that works, and it worked out just fine. Okay? So that's converting a 64-bit integer to a unsigned 32-bit integer. And I can say println and we can just do some prints to make sure that everything is cool. And there we go. Now, let's make sure, yep, these were zeros. So let's give these some actual values. I'm going to say 1, 2, 3, 4, 5, 6. Let's give those some actual values so we can actually make sure it works. And it seemed to work out pretty good. So it converted a 64-bit. Now, how does it do that? Well, that's what the as does. That's what that conversion does. That's what that typecasting does. You can also do it from integer to float. So I could say integer 32-bit equals float 64-bit as U32. And we're going to go ahead and copy that. And let's see how that works. And you can see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now, notice that the decimal 6, 7, 8, 9 is no longer there, because that's what the as does, is that it converts it from a floating point to an integer. Those are represented completely differently in the computer CPU and the CPU and the floating point unit. And integers don't contain decimal points. They don't contain fractional portions. I can go from an integer to a floating point. So I can say, so I can say a float 64-bit equals integer, and let's do 64-bit as integer, or no, float 64. And then I can say println integer 64-bit to float 64-bit is, and let's see how that works. And it's 456. Now you always want to make absolutely sure. So the unsigned 64-bit integer was 456, and it looks like it's 456 there. Now I always like to make absolutely sure. So I'm going to say float 64-bit equals float 64-bit plus 0.3456. Now it may require a 0 in the beginning. So let's make sure that we've got some valid fractional data in there. And we certainly do. Now, if you're interested on how to only print out, like, let's say 2 of those decimal points, go ahead and take a look at my STD, standard IO, and standard ERR video for Rust. I show you how to justify it, accuracy of the decimal points. I have all that in there for you. Okay, so we went from integer to integer, different sized integers to different sized integers. We went from integer to float. We also went from float to integer. Let's see what else we want to do. One thing I do want to mention is that, we talk about this, I talk about this in my data types video, is that if you have very, 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 very small numbers, or even very, very, very large numbers, it's always a good idea to represent them as float 64. However, if you're going to have small floating point numbers like dollars, currency, things like that, unless of course you're, I'm not going to mention it, but you want to stick with float 32 because you don't want to use up more memory than you need to. You always want to stay to the correct size. Same with integers and everything. Okay, so something else you can do is you can also convert a char into an integer. Now, why would you want to do that? Well, a char is actually an integer value in memory. In fact, there are no characters. There are no strings in your computer. They're all numbers. So if you would like to see the size, what the value of a character is inside the computer as an integer, you can do that. So what I'm going to do is I'm going to say integer 32-bit equals a char as unsigned 32. Now a char is the letter Z. So let's go ahead and do that. And I'm going to say print ln our char's integer value is and you can see that the capital Z has a value of 90. Now I'm going to go ahead and put print ln Now, if you're not sure what this means about Z being the value 90, again, look at my Rust data types video, but I'll show you right here. There's a website called ASCII-table.com. And in ASCII table, it actually shows you what the actual numeric value is of every character that you can enter on the keyboard, and even more. So I'm not sure what these, oh, Gerber, okay. So let's find the letter capital Z, and that's right there. And guess what? The letter capital Z is represented in memory as the number 90. If I want, I can change this to a lowercase z just to prove to you that I'm not crazy about this. And we can see it's 122 for lowercase z. There's the lowercase z 122. They also show you the hexadecimal and the octal values for those. And again, in my Rust data types or standard out printing to the screen video, I show you how to print things in hexadecimal or octal. So that's how you can see. So let's say if you had an entire string and you wanted to print off the ASCII value for every one, why you would do that? Kind of a specialty program, but you could do that using this casting. You can also convert an integer to a char. So let's go ahead and put, let's find a value, let's capital T, 84. So what I'm going to do is I'm going to say integer 32-bit equals 84. Now, why would you do this? Well, maybe you would get this number from a file or something like that, or maybe some kind of a temperature sensor or something like that where it says here's the ASCII values, but it doesn't communicate in strings, it only communicates in numbers. So you might get something like that. So what I'm going to do is I'm going to say so that's equal to integer 32 bits equal to 84. I'm going to say a char is equal to integer. Well, you really can't convert. It actually won't compile. So let's do this. Let's do that. I like that. I like errors in compiling because it's how you learn. And you see you actually have an error here. You can't convert a 32 or 64-bit integer into a char. It must be an 8-bit integer. So I'm going to say integer 8-bit. And this makes complete sense to me because the ASCII table is really just a byte. The largest number can just be held in a byte. So, okay, now it worked. And we didn't really do anything with it. So I'm going to say print ln our char value is now. And I think we should get, what did I say, 84? 84 is the capital letter T. Let's see if it prints the capital letter T. And it does. There's our capital letter T. So again, these ASCII values, these integer values, are what's used inside the computer's CPU to represent characters. That's just how it works. Now, I mentioned a moment ago that you couldn't do a 32-bit number. Well, you actually can. I'm going to say integer 32-bit equals, let's say 85. Let's do a U. So you can force it. It's not as pretty, but you may not have an 8-bit integer sitting in your program. You don't want to create one. So I'm going to put 85 in integer 32-bit. I'm going to say a char equals char from unsigned 32. I'm saying there's a function out there in Rust that says I want to convert from an unsigned 32-bit, and I'm going to say integer 32-bit. But you do want to put an expect in there, so I'm going to say expect invalid 32-bit to char conversion. And let's go ahead and print it. It should be U. There's U. So you can do it. I don't think it's as pretty because it's got just a lot of stuff going on here. It's not as clean. I shouldn't say pretty. It's not as clean in my opinion. And that's arguable. But it works. So you could go for 32-bit. I wonder if you could do 64-bit. Never tried that before. So let's say integer 64-bit. Let's make this 86. I have a feeling it'll work, but might not. I've seen stranger things happen. Okay, it didn't do it. So function associated item not found in char. So char doesn't have a from an unsigned 64-bit. It can only do it from 32-bit. So not sure why they did that. The Rust language is still evolving. I probably, if I was writing the Rust compiler, I would have made things common across both 32-bit and 64-bit, but they decided not to do that. So that won't work. I had never tried that before, and so I'm really glad we did that. Now, converting a floating point to a char or a char to a floating point is a little more involved. Not sure why you would want to do that, but you can do it. But how would you do it? So let's say a floating point to a char. And I'm not going to write the code, but to do this, convert the floating point to an integer, 8 or 32-bit, convert the integer to a char. Okay, couple extra lines of code. A char to a floating point. I think you're gonna understand how you do this. You convert the char to an integer. Then the second step is you convert the integer into a floating point number. So I'm not going to write that code for you because we pretty much already did this. I'm going to leave that up to you to play around with that, but that's how you do that. Now, something that a lot of people like to do specifically in keyboard input, and we did this in the keyboard input video previous to this one, and that's converting a string to an integer or a string to a floating point. Now, to do that, I'm going to say, so converting a string to an integer, let's go ahead and create it. Did we create a string up here? Oh, we did. So a string int and a string float. All right, let's do it. So I'm going to say integer 32-bit equals a string int. So that's my that's my variable, that's my string. Wherever I got that, I might have got it from the keyboard, I might have got it from a file. So a string int dot, I'm going to do a trim. Now what the trim does is it gets rid of all of the white spaces on either side of the number, on either side of the real data that's in there. So I'm going to trim it, and then I'm going to parse it as unsigned 32. So that is the code to do that. Now it's always a good idea to then say expect if there's an error, if it fails, when the program panics, it's actually going to display that error parsing integer. You might even want to put the line number of your code or the function or whatever. Okay, so I'm going to say println your integer from string is, and I think I typed this in wrong up here. All right, your integer from a string is 1, 2, 3. Now let's make sure. Let's take a look at a string int up here. A string int is 1, 2, 3. All right, great. You can do the same thing with floats. So I'm going to go ahead and just paste that. And I'm going to say float. And let's do something interesting. Float 64-bit. A string float. Float 64. Your float from a string is, and let's make that 64. And there's your 456. Again, you need to make sure, was it 456? Well, no, it wasn't. We have a problem here. So it's 123.45. Let's make sure. So float 64-bit, trim parse float 64. Oh, I printed the integer. That's why it's always good to check your data. And there it is, 123.45, 123.45. All right, the next thing that a lot of people like to do is going from a number to a string. And so let's go ahead and do that. So just so we can have some valid values here, I'm going to say integer 32-bit equals, I don't know, 6, 7, or 7, 8, 9. Float 32-bit equals 456.789. So now how can I put that into a string? Now let's find the string. So let's do, let's create another string variable. I'm going to say let mute a string. Let's make sure I have that syntax right. Yep, I do. So we're going to call it a string. And so what I'm going to do is I'm going to say a string. This is very simple. This is one thing I really like about Rust. A string equals integer 32-bit dot to underscore string. Let's save and build that to make sure I've got that right. Looks good. And I'm going to go ahead and print that. And while we're at it, let's go ahead and do the float. Let's save and build that. And there you go. So 789.456.789. So converting from an integer or a float into a string is very, very easy. You simply use the toString function, which is part of the standard library. All right, so that is type conversions called casting in Rust. We went from a integer to a float to an integer. We went from a char to an integer. We went from an integer to a char. We even talked about going from a float to a char, or going from a char to a float. I'm going to leave that little bit of code to you. But then we also did the string to an integer, the string to a float, as well as the string and the float to a string. Or I should say the integer and a float to a string. And if you want to learn more about the expect, if you take a look at my keyboard input video, you'll actually see the results of the expect, how the expect actually works. And I am going to have a separate video on expect and unwrap. We're going to have videos on those as well. But until then, keep on rusting.